So this question is checking that you understand what is meant by an annihilation, and then you have to make the conversion of energy into the frequency of the gamma radiation. So there's a few things, and it does say two gamma photons. So we've got annihilation of a muon, and that would require me to then look, and you can probably hear me rustling, look in the data sheet for the mass of a muon, which I should be given, and I am given, and I'm given its rest energy. So that helps me a little bit. So 1.056, I'm probably not going to need that number of sig fig. So I've got the rest energy is 1.5.659 MeV. So that's the energy if all of the muon's mass was converted into energy. I can convert it into joules. So by converting it into joules, this is going to be a very large number in EV, because EV is a tiny unit of energy. And converting it into joules, I multiply it by 1.6 times 10 to the negative 19, and that will end up with a much, much smaller number. So it's 105.659 million, because it's MeV, and then times by 1.6 times 10 to the negative 19, and I should get a much smaller number, and I do, and I get that is 1.69 times 10 to the negative 11 joules. So that's the energy released by, if I was to convert all of a muon's mass into energy. Now, muon, anti-muon annihilation, I'll have two lots of this energy. So I'll have two lots of this energy available. So I could multiply this by 2, and I end up with 3.38 times 10 to the negative 11 joules available. But then I produce 2 gamma rays. So each gamma ray, to conserve momentum, you end up with 2 gamma rays back to back. It tells you this. It tells you this in the question to help you. So I divide by 2 and I'm back where I started, which might seem a bit silly, but I think it's important that you understand what's going on, because in a calculation, in a longer calculation, you might be required to show that you understand that these 2 muons then produce 2 gamma rays. So rather than making a couple of mistakes and missing off the fact there's 2, can still get you the right answer. So this is the energy. Then it's E equals hf to find the frequency. So F is E over h. H is Planck's constant. So we end up with 1.69 times 10 to the negative 11 divided by 6.63 times 10 to the negative 34 Planck's constant. So 1.69 times 10 to the negative 11 divided by 6.63 times 10 to the negative 34 gets me 2.55 times 10 to the 22, and the units are hertz, which is C.